In this video, we are going to see about PSK, phase shift keying. Already, we have seen what is binary PSK and what is differential PSK. Here, we are going to see about QPSK, quadrilateral phase shift keying. QPSK is one signal is represented by 2 bits. So, 4 possible combinations there. 0, 0, 0, 1, 1, 0, 1, 1, 1. So, to represent 4 possible combinations, we need 4 phases. Thus, we come into the concept QPSK. When we say about OQPSK, it is offset quadrilateral phase shift keying. That means we are introducing a delay in QPSK. That is OQPSK. If we introduce the delay TB, then it is called offset quadrilateral phase shift key. As I have already said, in QPSK or OQPSK, one signal is represented by 2 bits. So, when one signal is coming, weight is 1 over TB. TB is bit transmission rate. R data rate. So, TB bit transmission time. So, when one signal arrives, here there will be 2 bits. So, that 2 bits will be split. That 2 bits will be serial, 0, 0 or 1, 0, 1, 1. So, that serial 2 bits, 2 bits in one signal, that 2 bits will split into the parallel. So, this is 2-bit serial to parallel converter. That serial combination is converted into parallel. That 2-bit will be split and converted into parallel, and odd combination will be transferred to IT channel, and even combination will be transferred into QT channel. Odd combination means first bit, third bit, fifth bit. That is odd combination, and second bit, fourth bit, sixth bit. That is even combination. Even combination will be transferred to QT. And in OQPSK only, you will have the system to give delay for TB seconds. TB is transmission or time for the 1 data bit. But this setup is present only in OQPSK, not present in QPSK. That's why we are denoted by dotted line. And this is Harrier oscillator, which is going to produce Harrier frequency for the modulation. From the Harrier oscillator, here cos2 pi FCT by root 2. Signal will be out. And here, the opposite with the pace change will be produced and transferred here. Minus sine 2 pi fct in over pi 2. And finally, these both signals will be out as the combination of SG. When we see in a deep manner, here the resultant ST formula in ASK, that is, as we have seen, that is A cos 2 pi fct. And in the frequency shift keying, that is also A cos 2 pi f1. Here, since frequency is changing, we are not using the higher frequency for the frequency. But here, we are using the different formula for the QPSK. That is, we are using this kind of formula for calculating SG. Here, IT is the channel. So that's produced the IT wave, and this produced the QT wave. When going for the QT channel, we are giving sine wave. And for the IT channel, we are giving the Hauss wave. And we have to subtract one from another. Variation of QPSK is known as OQPSK. That is offset QPSK, or we can say it as orthogonal QPSK. The difference between QPSK and OQPSK is we are introducing the delay of 1 bit chime, that is TB, because we have already seen data rate is 1 over TB. So TB is the time needed for the transmission of 1 bit. And here we are introducing the delay for the 1 bit. So the difference is for the QT channel, we are introducing the delay. That's why we are denoted by subtracting this. So the difference between both formula is only the delay. Otherwise, the formula is totally the same. OQPSK differs from QPSK only by the delay in the Q stream. Otherwise, all the spectral characters and bit error performance are same as the QPSK. When you see this picture, you can understand everything is one element, one signal. One signal is represented by 2 bits. So here we are going to transfer 5 signals, which is the combination of 10 bits. Here we are denoting binary zeros as the -1. -1 means normally binary 0 and 1 means binary 1. Here, as I have already mentioned, odd bits will be transferred to the I channel and even bits will be transferred to the Q channel. You know that 1, 3, 5, 7, 9 are odd numbers. So they will transfer to the I channel. And 2, 4, 6, 8, 10 are even numbers. So they will transfer to the Q channel. And this is our input signal. Here we are going to convert digital data to analog signal. So this is digital data. We have to combine it for the analog signal. So in IT, what's going to happen is the first wave will be transferred, that is 1. So it is maintained. And here also 1. So that is maintained. And here -1, that means 0. So change. Here -1, so here, and 1 again here. And for the QT, even number will be transferred. For the 2, it's -1, that means 0. And for the 1, this is 1 and -1 similarly. And as the combination of IT and QT, final phase of the output signal will be produced. And here you can able to see 4 different combinations. Here there are 4 combinations: 1, 0, 1, 1, 0, 0, 0, 1. And these 4 different combinations going to display by 4 phases: -4, -pi/4, pi/4, -3pi/4, and 3pi/4. And in OQPSK, we are introducing the delay for the Q channel. So the Q output will be delayed for the TB second. That is half of the signal. Because data rate is TB and 1 signal contains 2 bits. So TB is half of the signal, 1 bit time. So everything will be shifted forward. As you can see, everything will be forwardly shifted by half of the signal. And as the resultant of these two, OQPSK produce the output.